Hello, welcome to another video. Here is the question. Find a symmetrical equation of the line, this one, which is 4x plus 4y minus 5z, which is equal to 12, and 8x minus positive 12y minus 13z, which is equal to 32. Here are plane equations. This is an equation of plane. This is another equation of plane. The intersection between two planes gives a line. Here, the plane is of the form line a1x plus b1y positive c1z, which is equal to d1 a2x plus b2y positive c2z, which is the two. Here A, B, and C are the point of the normal vector. Let's call N1, which is a normal vector to the plane 1. This is A1, B1, B1, and C1. While the normal equation to the plane, this is A2, B2, C2. To find the direction vector of the line of intersection, we need to find the cross product of this N1 and N2. Here, let U be the direction. Here is the direction vector of the line of intersection. So this U is equal to the cross product between N1 and N2, and this U will be perpendicular to both N1 and N2. This is how we are going to do it. To continue, our U, which is the cross product between N1 and N2, here N1 is having the coordinates according to our equation 4 minus 5, while N2 has the coordinates 8, 12, and negative 13. The cross product N1, N2 is then equal to, we write the determinant. You find the determinant of the matrix. Here I, J, and here K. Insert this 4 minus 5, 8, 12, negative 13. Here U is equal to, we hide this and write the remaining. It is I into 4. The last was this 4, 5, 12, negative 13, negative J. Hiding this and this, we remain with 4, 8, 5, negative 13, positive K. We'll hide this like this. It's 4, 8, 12. This direction vector U is having the coordinate. Here it's this times this is negative 52. This times this is 60, but negative. This is 60. negative j. This times this is 50, negative 52. This times this, but here is negative, I guess. This times this is negative 40 minus become positive 40, then add k with coordinates. This times this is 48, negative this times this, it is 32. As you see here, our u is gonna having the coordinate this and this is 8i minus this and this is negative 12 times this negative, this is positive 12 j. This and this is, I guess, 16. It's 16. As you see, here is positive 16k. U can simply be written as a vector. Here is a vector equation, and it can also be written as 8, 12, and 16. This is U. Remember, our line was 4x plus 4y minus 5z, which is 12. Again, 8x plus 12y negative 13z, which is 32. We are going to find the point through which our line of intersection will be passing through. To find that, we can let x to be 0 and solve the system involving x and y. We can let y to be 0 and solve the system x and z involving x and z as independent variables, or we can let z to be 0. Let z to be 0 here. We stay with equation 4x plus 4y because z here is 0. This is equal to 12, and here 8x plus 12y, which is 32. Both these two equations are can be divided by 4. Dividing 4 here everywhere, 4 here everywhere, we have x plus y, which is 3, and 2x positive 3y, which is 8, I guess. We are going to eliminate. But here, I can find x as a function of y. This is 3 minus y. And take this x here. Taking x here, we have 2 into, I'm sorry, I am sorry for that. Let's keep continuing. Replacing x, which is 3 minus y in the equation 2x positive 3y, which is equal to